So we're back again with example 4. The national average rate of return on an investment is 10%. And so right now, for instance, home rates for a home loan is ridiculously low, like it's about 2% or something silly. You can get most car loans for less than right around 5% today. And so actually investing money does have a better return than what we typically pay for loans. And so this average rate of return is based on all time from the 1970s to today. So this is not just a Bush or a Clinton or a Biden or a Trump return rate, behaving how the economy was behaving. This has been how the United States economy has performed on average from the 1970s to today. So regardless of who our president is or what the political situation is, you can predict that most investments are going to have an average return rate of about 10%. So based upon this, if $5,500 is invested into a Roth IRA, and we will definitely talk more about Roth IRAs as we get into Chapter 6, and compounded monthly, the future value of the investment at any time t in years is given by this function. And so we are going to graph this function in GeoGebra once more. How long will it take for it to double, reach 50,000, 100,000? And we're answering basically the same questions that we did on the previous one there. So let's go ahead and swing it into GeoGebra. And I'm going to try something different here and see if I can delete the one that's there and then replace it and see if that works for me. It did. Awesome. So the other way to do that, everyone, again, is to go over here and say new, but then you've got to play with your axes again. You can see that this one is growing a little bit slower. It's not quite as steep as the other one was. And the reason for that is in example 3, we had a 12% return. Now we have a 10% return. Still a pretty good return, just not quite as aggressive or fantastic of a return rate for this one. So let's go ahead and run example 4. I'm going to put some math down on my iPad, and I'll be back and ready to put it in GeoGebra after I pause so that you don't have to sit through my writing. So I am ready to go. I've got my my math written out here. And so we are just basically putting 10,000 in for, or 11,000 in for S, because we are wondering when is the future value of this thing going to be $11,000. And it's probably, again, easier if you just copy straight from the presentation and drop it into Wolfram, but I'll take the time right now, since I'm already doing it, to go ahead and type it. And this will solve for T for us, which is going to be in years. And so it will take about 8.4 years for the value of the investment to double. Okay, and I did forget to write here that T is equal to, and again, I'm rounding to the nearest tenth, 8.4. So it will take about 8.4 years for the value of the investment to double. Let's continue on with what else we've got here. So for part C, how long to reach $50,000? Part D, how long to reach $100,000? And so again, we're going to bump it in here, 50,000. So let's see what Wolfram has produced for us. Wolfram says 26.7 years. So for part C, 26.7 years to reach 50,000 bucks. Still not terrible. We left only $5,500 in there, and it's grown to $50,000. It's grown nearly 10 times in 26 years. Not bad for doing nothing. You made about $45,000 for doing nothing in 26.7 years. Let's take a look at the same thing for $100,000. And remember, 26 times 2 is 52. So if it was growing at the same rate, it would take 52 years to double again and be $100,000. It is not 52 years, it is 35.1. So for part D, 35.1 years to reach a value of 100,000 bucks. So only 9 years to gain another $50,000. And for part E, as we mentioned before, in the other problem, I'm just going to shorthand it in this one. It is growing way faster. Nothing has changed except for the money has been left in there longer. Time is fertilizer for money. So for part F, how long to reach $150,000? How about $1 million? Let's run it. If we just left it alone for an extended period of time and tried to let it go to 150,000 bucks, let's see how long that takes. The 39.99, so 40 years. So in 40 years, to reach $150,000. That's pretty wild. So again, we have gone from in 5 years now. So it took 9 years to go from 50,000 to 100,000. Now it took only 5 years to go from 100,000 to 150,000. So between here and here, we gained another $50,000 in only 5 years, where here it took 9. And so again, as we can see, the money is growing faster. And so the million, this is probably going to take a while for this investment to do that, but probably worth just taking a quick look. It would take 63 years to reach $1 million. So again, not bad considering that we only started out with 5,500 bucks. And also considering that this is a lump sum, this is compound interest, this is a lump sum that was only deposited once. There was no money added to the account ever. So that's it for compound interest, everyone. I hope these examples are helpful. I hope you find that the problems that follow are sort of fun and real life. And I hope you find them to be super informative for yourself and your future.